Once we have defined the graphical interface part, let's create a model that will allow us to store the information of the application to calculate the body mass index. Let's go then to the folder called Models and let's add a new class called, for example, BMI. This class is going to be a public class and we're going to add some floating type properties to it. The first one is the height property. The second property is called weight. And finally, a last property called result. Once we have created the model, we're going to create the view model. For this, let's create a class in the view model folder and call it VMI view model, following the nomenclature that we studied in the MVVM section. Let's define the class as public and let's create a property of type VMI called VMI with its respective get and its respective set. In this case, we see that we have an error that is indicating that VMI is a namespace, but it is being used as a type. What does this refer to? Well, the error refers to the fact that the project is called VMI and the model name is also VMI. So Visual Studio does not know which reference to use. What we can do is to use the full name of the class, which in this case is VMI MVVM models, and with this we can use the class called VMI. As part of the suggestions of Visual Studio, we see one that suggests to simplify the name and to leave only models.vmi. Once we have done this, let's proceed to create a constructor for this view model. Inside the constructor, let's create a new instance of the class and assign it some values such as an initial height equal to 180 and an initial weight equal to 73. Let's proceed now to bind this property called VMI from the XAML code. Let's go back to the XAML file and go to the region called height, where we will replace the value of the linear content pointer by a binding equal to VMI.height, which is the name of the property that we have created from the view model. Let's do the same in the region called weight. Let's look for the control type linear content pointer and let's change the value for a binding equal to VMI weight. Before testing the application, we have to indicate that the binding context is equal to a new instance of the view model. For it, we go to the vmiview.cs file and we specify that binding context is equal to a new instance of VMI view model. We have to import the namespace that is needed. Let's test that everything works correctly. Once the application has started, we can see how the binding has been applied correctly. We can see this because the initial value of each of these controls has a value that we have specified in the view model, that is, the value 180 and the value 73. Let's stop the execution of the application, since the next step is to implement in the model the property called result. We have to take each of these properties, perform the corresponding calculation, and assign to the result property what is the result in order to bind it to the graphical interface. To perform that task, we must convert the property into a complete property. In fact, as part of this property, we can remove the set, since we will only get the information of the property and not assign a value, because the data will be obtained directly from this pair of properties. Let's indicate then that as part of this property, we want a get. Let's add a pair of braces, and inside the get, let's return the result of the calculation of the body mass index, which in this case is weight between height. The result between height again, and the final result should be multiplied by 10,000. Now that we have made the calculation, let's proceed to copy the name of the property and return to the XAML file to indicate that the pointer of the radial gauge control does not have a static value but a binding to VMI.result. Let's test the application. Once the application has been deployed, we can see how the control has in the needle property the result that has been calculated when starting the application. However, if we move any of the sliders, the result is not reflected in the graph. This, as you can guess, happens because we have not implemented the iNotify property change interface to notify updates to the graphical interface. To perform this action, we're going to install the Nugget package called foddy to implement the iNotify property change interface automatically. Let's find the property change.foddy package. Let's install it as part of the project. And once the package has been installed, let's go to the class in which its properties are being changed. In this case, it is a class called VMI, which is the model, since this is where the property called result is being modified, and it is where the graphical interface must be notified that a change has occurred. So let's proceed to implement the interface through the add iNotify property changed interface attribute. We have to add the namespace that is needed, and once we have added the attribute, we're going to test the application one more time. We have the application here. We're going to move the sliders and notice that this time the calculation is already being performed, which is being reflected in the radial gauge. In this way, we have already implemented the iNotify property change interface to notify that a change occurred to the graphical interface. The last step is to modify the string located at the top, which is going to show the result of the calculation. For this, I will stop the execution of the application, and we're going to create a new property in the model that is of type string and that is called result text. Let's leave only the get in the property, and inside I'm going to paste a set of lines of code so that you don't have to see me writing them. What we are doing is to create a template of the final string that will be shown, and we are carrying out the comparison of the result obtained in the result property. In each comparison of the VMI result, we are doing a replace of the hash symbol by the final string that will be shown to the user according to his VMI level. We perform a series of comparisons according to different intervals. The last step is to bind the result text property to the graphical interface. To do this, let's go back to the XAML file. We're going to look for the label control that interests us, and we're going to change this text by a binding to vmi.resultText. With this change applied, let's start once again the execution of the application. Notice that this time we are already showing the user through the graph what is the result of the body mass index calculation, and we are also indicating through the text string what is the result obtained so that the user has a better idea of what their current status is.